Hello everyone, am I audible?
Yes, sir.
All right, everything good, Shikani?
Yes, sir.
Any doubts from the last class?
No, sir.
Ronaldo Kulsum? Everything is good, no doubts?
No, sir.
All right. All right. Let's move on then. In the last class, we learned how to check one function, right? If a function is one or not. Shikani, can you tell me how to check that?
Sorry, can you repeat?
What did we do in the last class? Do you remember?
Yes.
Tell me.
To prove one.
One. Right. So how did we do that?
If all elements of A have only one relation to B.
Right, that was one function. But how to check that? What was the method we used?
Sir, I don't remember.
We did this, right? F of x1 is equals to f of
yes, I remember now.
x2, right? And if this bring out that x1 is equals to x2, then the function is 1. Otherwise, it is not 1, right? If you get 2 or many values of x1, right? Everyone remember this? Kulsum, Ronaldo, this is clear, right? All right. So now we are going to learn how to check onto or subjectivity. Surjectivity of a function. Suppose I have given you a question function from R to R such that f of x equals to x cube plus 2 for all x belongs to R. Alright, suppose I gave you this function and I ask you what is the surjectivity of the function. Is it onto or into? Alright. I hope you remember what is onto. Can anyone tell me?
When it is 1 and into, then it's onto.
All right. Then what is bijective function, Shekani?
I think I said the opposite.
Right. So what was onto function? Kulsum, what is onto function? And what happened to your mics, Ronaldo, Kulsum? Syed, everything good?
Yes, sir.
Like no doubts from the last class, right?
No, sir.
All right, we just started the lecture. We are going to learn how to check surjectivity of a function. What is surjectivity? Syed, do you remember what is surjectivity of a function? What is onto function? Do you remember?
Yes, sir.
Tell me, what is a onto function?
Sir, f of f such that a to b, all elements of b is an image of element in a, then f is onto.
Absolutely right. That is onto. We are going to check about that only, right? So, in what do we say? In layman's language, what we say? If all the elements of set B is connected to at least one element to set A, then this is onto, right? All the elements of B should be related to A, right? This is onto function in easy language. All right. Shekhani, this is clear?
Yes, sir.
All right. So who can tell me what is set A here in this question? What is set A and what is set B? Who can tell me what is set A and what is set B here?
Rational numbers.
Rational number. R is rational number or real numbers?
So it's a real number.
Real numbers. Set A is real numbers. And what is set B?
Same, sir. Real numbers again.
Same, real numbers. Absolutely right. All right. How did he say this? Because here, this is R to R. Always a function is written as set A to B. So this later one is set B. The first one is set A. Alani, this is clear?
Yes, sir.
All right. Kulsum, Ronaldo, this is clear? All right. So onto function is nothing, but if we prove that the range of this function is equals to real numbers, right? Because the codomain is real numbers. That means if you prove that range is also equals to codomain, then this is onto. Or if we prove that each element of set B is connected to at least one element of set A, then this is onto function. All right. So how we can do this? This is a standard step. So it is good if you know how to solve. All right. What is the first step? Let y belongs to R. All right. Y belongs to R. Y is an element. This belongs to R. Which R this R represents? Codomain. All right. We are taking an element from this set B. All right. That is why we mentioned that codomain R. All right. Such that f of x equals to y. All right. Such that the function is equals to y. All right. Now what is the function here? The function was x cube plus 2. Right. I can replace the function value. The definition of function x cube plus 2 is equals to y. Now our goal is to write x in terms of y. All right, write x in terms of y. So what we can do, take this to this side. So x cube is equals to y minus 2. And then we can write x equals to y minus 2 to the power 1 upon 3. Are these steps clear? What I did here, everyone? Shikhani, Syed, Kulsum, Ronaldo, steps are clear? What I did till now?
Yes, sir.
All right. Now, what did I write here? We wrote x as a function of y. What was y? Y was an element from codomain, right? If this is set A, this is B, which both are real numbers, I took an element from set B, all right, and I tried to find, can I find an x? What is x? X is an element of set A, right? This is understood, everyone? X is an element of set A, y is an element of set B. Now, what is y? Y belongs to real numbers. So y can be any real number, right? Side, this is clear?
Yes, sir.
So can anyone tell me, if I put any real number here, what value can I get? What will be the range of values I can get here? Or let me reframe this question. Is there any real number y, if you put here, that will give us either infinite or imaginary number? Is there any y which I put here that will give us infinite or not defined and imaginary number. Think about this. Did you get my question, everyone? Shikhani, Said, Kulsum, Ronaldo, what I said? Said, is the question understood?
Yes, sir.
All right. Then do you have any answer? Ronaldo is saying 0 to infinite. All right, I'll explain once more. I'm asking, is there any value of y? Where will you find the values of y? Y is any real number, right? From codomain. Is there any value of y which if I put it here, suppose I put y equals to 2. So 2 minus 2 is 0, 0 to the power 1 upon 3 is 0. So I'm trying to find any number which if I put here will give me either not defined or imaginary. All right, how do we find how do you know number is imaginary? If I have negative number inside the square root, right? That is imaginary. So try to find any value of y which will give us some trouble, because this is infinite is double, imaginary numbers are double. All right, Kulsum, the question is clear. All right, Ronaldo, how do you know this is 0 to infinite, and what happened to your mic? Syed, did you have any answer? Shikhani?
Yes, sir.
Any answers?
No, sir.
All right. See, we have x equals to y minus 2 to the power 1 upon 3. See, if you put real numbers are generally divided in, we can divide in 3 parts: negative numbers, 0, and positive numbers, right? So if you put any negative number, suppose I put minus 5. So minus 5 minus 2 is minus 7, and minus 7 to the power 1 upon 3. Is it imaginary or not? Can anyone answer this to me? Is it imaginary or not? Ronaldo, Kulsum, Syed, Shikhani, is it imaginary or not?
Yes, sir.
Yes. No, this is not imaginary. All right. If I have minus 7 to the power 1 by 2, then this is imaginary. All right. You can write this down, everyone. All right, write this down. If you have even powers, all right, or reciprocal even powers of negative numbers, then it is imaginary. All right, reciprocal odd powers are not imaginary. All right, because suppose minus 8 to the power 1 by 3. So what does it say? What number if you cube, you will get minus 8. So we can easily say minus 2, because minus 2 times minus 2 is minus 8. So we can say cube root of minus 8 is minus 2. But if I ask you what is minus 4 under root means square root. So there is no answer. Right? Understood this, Syed? Syed, Sekani, this is clear?
Yes, sir.
All right. I know this is a bit difficult part, but if you understand this once, then it will be easy. So we can move on. We can say that x equals to y minus 2 raised to the power 1 by 3. Negative numbers, if I put here, there is no issue. If I put 0, then this is minus 2 raised to the power 1 by 3. Okay, also that is also not imaginary. Positive powers, positive numbers, 5 minus 2, 3 raised to the power 1 by 3, that is also okay. So no matter what you put as y, we'll always get a real number from this, right? No matter what value of y you put, you will get a real number. So does this mean that from this set, no matter what value I put, there is some pre-image in x, because we are always getting a real number, and x is also from a real number, right? Set A is also real number. So no matter what element you choose for y, there is always a connection to set B, right? Is this clear or not? Everyone, is this clear or not?
Yes, sir.
All right, I hope you are understanding this. So we can say for all y belongs to R, y minus 2 raised to the power 1 by 3 belongs to R, right? So for all there exists a x such that f of x equals to, or x equals to y minus 2 raised to the power 1 by 3 belongs to R domain. All right. So this function is a onto function. Is this thing clear or not? Again, I'm asking Shikhani, is this clear?
Yes, sir.
I don't hear confidence in your voice.
Yes, sir.
All right, Syed, this is clear. All right, Kulsum, Ronaldo, this is clear. All right, let me explain once more. Let me rewrite this in a single page. All right. We said let y belongs to R. This is codomain. All right, Ronaldo. We took any value of y from the set B. All right. We have two sets, set A and set B. We took any element from set B and named that y, such that f of x equals to y. We took such an element that f of x is equals to y. So this implies that what was f of x? F of x is x cubed plus 2, and this is equals to y. We assumed y in such a way that this is true. So we can rewrite this as x cube equals to y minus 2, and this is equals to x is equals to y minus 2 raised to the power 1 by 3. All right. I hope this is clear. Now, what is y? Y is any number from the codomain, right? And what was codomain? Codomain is R. R means a real number. So y can be any real number, Any real number means from minus infinite to infinite, you can choose any value for y, right? Now this step is very crucial. You have to observe that no matter what value of y you put here, this result is always a real number, right? No matter what value of y you put here, the result is always a real number. Is this clear, Ronaldo? Why this is a real number? Right. So we can say that for all value of, or for all y belongs to R, y minus 2 raised to the power 1 by 3 belongs to R. No matter what value of y you put, this is always a real number, right? So can we say this? This is that for all y belongs to R, there exists. See, if this quantity is a real number, that means x is also a real number. Always, no matter what value of y you put, you are always getting x as a real number. And what is x? X is an element from set A, right? Set A is also real number. So no matter what value of y you put, there is a connection from y to x, right? So we can say for all y belongs to R, there exists an x such that x is equals to y minus 2 raised to the power 1 upon 3, which is a real number. And this is domain. So the function is an onto function. If you try to understand this diagrammatically, this is minus infinite, minus 2, minus 1, 0, 1, 2, 3, infinite. Okay. If I took minus 2 as the value of y, we are getting minus 2, minus 4 raised to the power 1 by 3. And that is okay, that is a real number. If you have cubic powers or odd numbers in the power, then it is okay. We don't get imaginary numbers. And this value is a real number. That means x is a real number. That means if I put any value of y, there is a connection, right? There is an x, which if you put in this equation, you will get y as minus 2. Right, Ronaldo? Is this step clear? What I said there? And that is what we are trying to prove, right? For all value of y, there is an x such that if you put that in the function, we get as y as the answer, right? And this is what this proves. No matter what value of y, there is always an x, which proves this is equal to this, right? So this function is an onto function. All right, I hope this is clear now. Shikhani, Said, Ronaldo, Kulsum.
Yes, sir.
All right, please note it down also. Have you noted down the question? Note down the question, and then this. The question was f from R to R such that f of x equals to x cubed plus 2 for all x belongs to R. This is the question. You have to check the onto, and this is the answer. rewrite the sentence anywhere. There exists an X such that y equals to x cubed plus 2. All right, done everyone? Solve this question. F from R to R such that f of x equals to x square plus 2 for all x belongs to R. All right, you have to check if this is onto or not. I'll give you a few minutes. Try to solve this one. The question is clear, everyone? Said, the question is clear?
Yes, sir.
All right, try to solve. Anyone solve this? Shikhani, have you solved this? Said, Kulsum, Ronaldo. Are you guys able to solve this? It's okay if you cannot solve this. Not on to. Absolutely right, Kulsum. Ronaldo, have you solved this? No answers. Let's see. Just a minute. All right. Right side, this is not surjective. Side, can you explain to me how to solve this?
Yes, sir.
These two.
Sir, it's given f of x is equal to x square plus y, x square plus 2. So f of x is y. So y is equal to x square plus 2.
All right.
Then, yeah, x square will be equal to y minus 2.
All right.
And then x will be equal to y minus 2 the whole raised to 1 by 2. So this is even 1 by 2. 2 is even. So its root value will be imaginary. So it cannot be budgeted.
And when will you find imaginary numbers? When you put y equals to a negative number, right? If you put y as a negative number, then you will get imaginary numbers, right? Otherwise, that is okay.
Yes,
If you
yes.
put, right, if you put y equals to 6, then 6 minus 2 is 4, 4 under root is 2. That is okay, right?
Yes, sir.
So that you have to write. All right. Then once you checked that this is not on 2, then there are two ways to write down the solution. One is this method where you do the absolutely the previous method what you did here. But I told you previously also, if you have to prove that something is not onto, then one example is enough. All right. See in here, what is set A? Again, this is real number. What is set B? Again, this is real number. Absolutely right, Ronaldo, not onto. So how you can prove this? Just give an example. This is real number. This is real number. So here minus infinite, minus 2, minus 1, 0, 1, 2, 3, infinite. Here also minus infinite, minus 2, minus 1, 0, 1, 2, 3, infinite. If this is onto, that means all the numbers here are connected with set A, right? But we can easily see that no matter what value of x you put here, we are not going to find negative numbers, because x is, if even if x is negative, x square is always positive, right? This value x square is always positive. So positive number plus 2 is always positive. So we can easily see that function has no negative value, right? We cannot get negative value from this function. So range of this function is always positive or 0, is not even 0, 2 to infinite, right? The minimum value of x square is 0 if you put x equals to 0. So minimum value of this function is 2. So you cannot get negative value from this function. So you can easily say that minus 2 or minus 4 or any negative number has no pre-image. So the function is not onto, right? Minus 2 is not connected with any element, right? No matter what value of x you put, you will never get minus 2 or minus 1 or minus 4, minus 5 and so on, right? Is this clear, Syed?
Yes, sir.
So you can just write this line and this will be proved. If you ever have to prove that something is not onto, not 1 1, then one example is enough. But if you have to prove that something is onto, then this method is to be followed, this whole method. All right, Ronaldo, Kulsum, Shikani, this is clear?
Yes, sir.
All right. Ishan, you are almost an hour late.
Sorry, sir.
Yes, and we did a very important topic. No problem. In the next question, I'll explain how to solve. All right, we are trying to find how to check a function is onto or not. What is onto function, Ishan? Do you remember what an onto function is?
Not clearly.
Not clear. If all the elements of set B is connected to at least one element of set A, right? No one should be empty here. All fathers must have a son, at least a son. That means that is onto. So we are trying to find how to check onto function, right?
Yes, sir.
So write down the question. F is from Z to Z. Sorry, Z to Z. Such that f of x equals to 3x plus 2 for all x belongs to Z. Let's try to check if this is onto or not. All right, the question is clear, everyone. And Ishan, have some patience. I'll explain in this question how to solve this type of questions. All right. It's not onto. All right. All right, let me solve this. Ronaldo, it's okay. So in this question, we have the function as 3x plus 2. All right. Again, let us see first what is set A and set B. Z means set of integers. So here, -5, -4, 0, 1, 2, 3, and so on are all the elements. In here also, -5, -4, 0, 1, 2, 3, and so on. Right. All the elements are there. For this to be onto, we should connect all the elements of this set to at least one element in set A. Right, this is onto. Ishan, is this clear? All the elements should be connected to set A. Right, so what is the method to solve? We say let y belongs to z. What is z here? Z is codomain. We are choosing one element from this set B, codomain, such that f of x equals to y. Let me assume y in such a way that f of x is equals to y. What is f of x? F of x is 3x plus 2. This is equals to y. Now the crucial step is to write x in terms of y. So this is 3x is equals to y minus 2. This implies x is equals to y minus 2 upon 3. All right. Now y is from z. Z is all integers. So no matter what integers should I put, I should always get an integer as an x, right? Because x is also an integer set. The first set is also integer. So if I put y is equals to 2, so 2 minus 2 is 0, 0 upon 3 is 0. So x is an integer. But if you put y equals to 0, if you put y equals to 0, then you get x is equals to 0 minus 2 upon 3 is equals to minus 2 by 3. And minus 2 by 3 is not an integer, right? X is not an integer for y is equals to 0. That means this value 0 is not connected to any x, right? Because x is always an integer. But if you put y equals to 0, that means you should always put x is equals to minus 2 by 3, which is not an integer. So 0 from this set B is not connected to any element in set A. So this function is not onto. Is this thing clear or not, Ishan?
No, sir.
Absolutely clear, right? And this is the specific method you have to solve. All right.
Yes.
Ronaldo, this is clear now? And again, as I told you, if you have to, you can see that this is not onto, then one example is enough. You could have just put this, that 0 is not connected to any element of x. So this is not onto. Please write down the solution if anyone wants and solve the next question. Show that the signum function f from R to R given by f of x equals to 1 if x is positive, 0 x is equals to 0, minus 1 if x is negative, is neither onto, neither 1 1 or onto. All right, I'll give you a few minutes, try to solve this one. Anyone solve this? Ronaldo, Said. Yes, Kulsum, what is the answer here? Or how do you prove that this is not onto or 1-1? See, they have broken down the function in 3 parts. All right. Function is from R to R. If the function is, let's erase this is 0. If x is positive, then the function gives you the value 1. If x is 0, then the function returns 0. If x is negative, then the function gives -1. Right? This is the function. So if I ask one of you, what will be f of -2? What will be the answer here, Ishan? What will be f of -2?
So -1.
-1, absolutely right. Because as soon as you see that x is negative, the function will return -1. They are saying if x is negative, give the value -1. All right. So what will be f of -3? Shikhani, what will be f of -3? Said, what will be f of -3?
So -1 again.
-1. That means for -2 and -3, we are getting the same result. So we can say -2 and -3 have same image. So this is not 1-1. All right, this is clear, everyone. This is not 1-1 because if you put x equals to -2 or -3 or -4, you get the same result. So this is not 1-1 function. Now on to how to check onto function. You will never get 2, 3, 4, 5, 6 or anything, right? The result is always 1, 0, -1. That means there does not exist any x for which y belongs to r minus -1, 0 or 1, right? So this is not onto function. Is it clear, everyone? Ishan, Shekhani, Ronaldo, Kulsum, Said. Half of you are, I think, already gone, thinking we cannot do this. Right, Shekhani, are you there?
Yes, sir.
Right, are you thinking like that? That this is very difficult. I'll leave for 2 marks. Not an issue, right?
No, sir.
No. All right. All right. Next question. Ishan, is this clear or not?
Sir, not very much.
Not very much. All right. See, please get the lecture, today's lecture. All right. So you missed 1 hour of class.
Sir,
So
I
that is
have
why
asked them to add me in the class. They have not added me in any class. They have not sent me any assignment as well.
you are not getting the links to the class.
Sir, they are just personally sending me the links. Other than that, I'm not getting any other like assignments, etc.
Assignments, you have to check the portal, Ishan. In the portal, you will get the assignments.
Sir, I'm not there in the portal.
They have not given you any password logins.
No, sir. No.
All right, I'll talk to the team today only. All right, no issue. And did you get the previous lectures right? You got the previous lectures?
No, sir, because they said that sir will give you some links, maybe something like that. They said that, and they didn't give any links for the previous lectures.
All right, I'll talk to the team today only, and they'll be sending you all of the details and the links. All right, don't worry.
Okay, sir.
All right, there is some, and also there the website is facing some glitch for a few days now, so might be that because of that they have not sent you, but I'll talk to them. All right, don't worry. Let's solve another question. Yeah. Show that the function f from n to n given by f of x equals to 2x is 1 1 but not only. All right, the question is clear, everyone. This you have to prove that this is 1 1 but not only. solve this? Anyone? Ronaldo, Kulsum, Said. See, 1 is very easy. We did that in the last class. To check a function is 1, let x1 and x2 belong to n such that f of x1 is equals to f of x2. This implies that 2x1 is equals to 2x2. This implies that x1 is equals to x2. All right, good, Kulsum. So f of x1 is equals to f of x2 implies that x1 is equals to x2. So function is 1, 1. Right, Ishan? This you remember in the last class we did this?
Yes, sir.
Right. So this is how we can prove 1, 1 function now on 2. Right. Let y belongs to, this is from n to n, right? So n, y belongs to n such that f of x equals to y. So this implies 2x equals to y. So this implies x is equals to y by 2. Now y is all natural numbers. So we can put any value of y here. So for y equals to 1, 1 is a natural number. So for y equals to 1, x is equals to 1 by 2, which is not a natural number. So function is not onto. Is it clear? For y equals to 1, we are not getting any natural number of x. Right? We have to put x equals to half to get y equals to 1. But 1 is in this set B, but 1 is not connected to any element of set A because x is all natural numbers. All right, Ishan, is this clear?
Yes, sir.
All right, please note it down, everyone. Syed, Shikani, Ronaldo, this is clear?
Yes, sir.
All right. Note it down. All right. Next question. Show that the function f from r0 to r0 defined as f of x equals to 1 upon x is 1, 1 on 2, where r0 is the set of non-zero real numbers. As the result 2, if the domain r0 is replaced by n with codomain being the same as r0. All right, try to solve this question. try to solve the first part. The second part I'll solve. Show that the function f from R0 to R0 defined as f of x equals to 1 upon x is 1 1 on 2. So you know how to solve for 1 1. Try to solve for on 2 also. All right. Syed, the question is clear.
Yes, sir.
All right, I'll give you a few minutes. Okay, anyone solve this? Kulsum, Ronaldo, Shikani, Syed, Ishan. Please explain. All right. See, here the two sets are R0 to R0, and they've explained what is R0. R0 is the non-zero real numbers, right? So remove 0, then what is left is R0. All right. So for 1, very easy. Same steps. Let x1, x2 belong to R0 such that f of x1 is equals to f of x2. So this implies that 1 upon x1 is equals to 1 upon x2. This implies that x1 is equals to x2. So f of x1 is equals to f of x2 implies that x1 is equals to x2. So the function is 1, 1. All right, very easy. 1, 1 function is very easy. Any doubts in this? Anyone? All right. For on to, let y belongs to R0 such that f of x equals to y. So let give me a second. F x equals to y. So this implies that what is f of x here? 1 upon x. So we can write 1 upon x is equals to y, or x is equals to 1 upon y. Right? I think this till this no one has any doubt. All right. Now y can be any value from R0. That means except 0 we can put any value of y. Now can anyone tell me, is there any value of y which if you put here will not be getting any real number? Kulsum, is there any value of y such that we are not getting real number from 1 upon y? No, that means no matter what value you put in here, there is a real number x which will give you y. So we can write for all y belongs to R0, 1 upon y belongs to R0, right? So for all y belongs to R0, there is a x is equals to 1 upon y belongs to R0 such that y is equals to 1 upon x. So the function is onto. All right. All of the y is related to at least one x. So the function is onto. All right. This is clear. Ishan.
Yes, sir.
All right. Said, Ronaldo, Shikani. This is clear.
Yes, sir.
All right. Note it down. The second part, please try at home. All right. What will change? They are saying what this replaced by n. All right. Domain is replaced by n. So this function will become n to r0. That is all that is changed. So please try to do that at home. All right. Note it down this solution. Tell me when you are done. Done, everyone? Ishan, Said, Shikani, this is done. All right. Now there is a test for 30 minutes. All right. I hope you guys are prepared. I'm sharing the test in a minute. Everyone, are you ready for the test? I hope.
Sir, when did you announce the test?
No, the test was not announced. This is, as you say, what you say, surprise test. All right, I have shared the test. So please solve it. You have 30 minutes. All right. Everyone okay with you? The questions are clear? Said, Shekani, Kulsum, Ronaldo.
Yes, sir.
All right. You have 30 minutes till 8:30 and you have to share the answer sheet on the WhatsApp. All right. So please start the paper.
Sir, who do we have to send this?
The number you receive all the WhatsApp notifications from,
Sir, I can't
or the
hear you,
links,
sir.
the links you receive from the WhatsApp number, right, Shikani?
Okay.
Right, everyone can start their video. The focus mode is on. All right, if you have the webcams connected, please start your videos. Shikhani, you have to start the video.
Sir, I'm done.
Who is done?
Sir, your
Shikhani.
voice is not there.
Well, Shikhani, oh, you have solved all the questions.
Yes, sir.
Alright, did you cheat?
Sir, what?
And did you use Google or anything like that?
No, sir.
No, all right. Send the
My
answers to the
yeah,
WhatsApp
okay.
then.
Sir, I cannot send. My dad is not at home.
That is not at home.
Yeah, he has the phone.
All right, you can. What you can do? Let me talk to the team if you have any other. I don't remember the number. All right.
Sir,
Give me a
if there is
moment.
email, I can send on email maybe.
All right, then give me a moment. All right, I'll be sharing the email with you. Just give me a second.
Sir, I'll be back in 5 minutes.
Shikani, I've shared my mail ID with you. You can upload the answer sheet on that. All right, upload on your drive, then share with me.
Sir, how should I send?
I've sent you the mail ID, so upload on your Google Drive and share with that mail ID.
Okay.
All right, or you can directly forward, send attachment as a PDF.
Okay, sir.
And Shikhani, don't spam. All right, that is my personal mail ID, so please don't spam that.
Sir, sometimes your voice doesn't come. Like your mic is on, but your voice doesn't come fully.
Like no issues. In the class, I was. Yeah, everyone is facing that issue. Nobody can hear me, or my voice is coming to all of you, but Shikhani. Can you hear me now, Shikhani?
Yes, sir, I can.
All right then, because I think the issue is because I was unmuting late. All right, I was like forgetting to unmute. All right, 5 minutes left for the test.
Sir, can you send your email address again? My battery finished, so my computer switched off.
Done. Have you got that?
No, sir.
Now?
No.
Look at the chat, Shikani. I've
Sir,
sent
it's
you.
not there, sir.
It is saying Shikani is not in this meeting.
So if you click on my name again, then it will come automatically. Okay, now.
All right, got it?
Yes, sir.
All right, everyone, please prepare your sheets. All right, and send that to WhatsApp. The time is almost over. Last 2 minutes remain. Kulsum, Ronaldo, Ishan, Said, Shikani. All right, everyone, the test is over. So please send your answers to the WhatsApp group or number. All right, everyone,
Yes, sir.
please send your answers to the WhatsApp link. And no doubts in the class, right? No doubts from this class.
Yes, sir.
All right then. So this is all for today's class. In the next class, we're going to finish this chapter and start inverse trigonometric functions. So please keep revising and complete the assignments in time. All right. Kulsum Ronaldo, I don't see any of your responses yet. All right. So this is all for today's class. Take care.